Hey guys, I've been doing a little bit more work on some of the BMS monitoring stuff. I've had a few queries from people, and I think it's got a bit of interest out there. So, been doing a little bit more work, and one of the big things is being able to see that data. Now, previously, I'd configured it so that the battery monitor you could connect for a web page, and you could see that, which is fine, and it had some uses. But really kind of want to take the next level and tying in with some of the previous videos I've done is the Grafana stuff. So what I've done is I've taken the existing code and added to it, and now it'll monitor the cell voltages of your pack for however many of the monitors you've got attached. At the moment it's a bit disjointed because what I've done is while I'm developing this, I'm just monitoring two small 18650 individual cells in the house, just for testing things out. But if this was hooked up with a full set for mine, there would be 7 bar charts here. So to show how I've done that, I've got the code up here. There's some new additions at the top, where you can set the IP address of the server or Raspberry Pi or whatever that's holding your influx DB. The port, the default is 8086, so you shouldn't have to change that. If you followed my past video, you'll see that there's we created a database called Powerwall, and we created an admin user root with a password root. You can of course change that anything you want, and you just have to change it here, just the once. I did look is just a bit of background for different things, and I found quite a few on GitHub for writing from an Arduino or an ESP8266 to InfluxDB, but for whatever reason I just couldn't get those to work. So the way that I've done it is to, if I scroll down here, is to do it as an HTTP post. If anyone wants to take this and modify it or has any better suggestions, by all means, really open for that. But this is the way that I've got it to work. Basically it's gonna form a string that shows what your influx host is, the port, and the database using those variables that you set above. So like I say, you can only need to set it in that one place. It's then gonna step through however many cells that it's detected when it was started up. So in my case there's only 2 cells there, and then what it's going to do is going to form this this post string, and these are the important part. These all gets written inside the InfluxDB. So it's going to create an item cell voltages, and then it's going to create an item below that cell. So this is going to iterate for me twice, so that's going to iterate cell 1 and 2 basically. Now I could have just named those cells 0 and cell 1, but I'd been doing some testing and I'd named them from 1 instead of 0 in Grafana. So basically I'm just adding 1 here and converting it to a string, and that's doing that post there. A payload's just getting the return response. You don't get any response from actually, yeah, you don't get a response, I believe, and then you get the code back, and you should get 204 if it successfully accepted it. And these are just 2 debug lines which you can take out, but I've just left in for testing. I've also left in the web server part for now. What I have done also as well in the code is changed the timeout to be 60 seconds. Not the most efficient way because it's going to kind of stop updates for the web server, but I'm kind of seeing this whole thing as a bit of an evolution and ongoing. And then what you will do is in Grafana, I'll edit this display that I've done, the chart, and so I've created a graph, and then in the metrics what you need to do is you'd go select from, so I've already selected the data source as the Powerwall, that database that we created. You go, and I'll tell you what, I've created the 2 here just because I'm testing with 2 cells, and what you would need to do is you need to create one of these for each of your cells that you've got. So if you've got a 7S pack, you need 7. If you've got more than 14, say, for 14S pack, you'll need to create that as well. So if I create another one, it'll automatically populate that. Select measurement. These are all the ones that we have available. I'm going to scroll down to cell voltages. Where from, automatically populates it with cell. Now there's only been values entered for cell 1, cell 2. If this was a 7S pack, you should have 1 through 7 there, but I can get that ready and just say cell 3. Field value we are going to remove, and we're going to select the last. When I'm importing it, it's just doing it as a 4-digit number. So what we need to do math. Click there, change that to 1000. Time interval, doing as 1 minute. And then if you don't change the alias by, what you'll basically get, instead of a nice cell 2, if I just take that out there and go here, you'll get basically the field it's pulling it from and the selector that you're using. So if we put cell 2 back in there, it's just a small visual thing, but it just looks a lot better. So before we've done that, it actually hasn't populated anything there because there's only been 2 cells worth of information being put in the database. So yeah, so a very quick and short one, but that'll allow you to do that. That's been a bit funky there. There you go. You can hover over, so that's showing 3.877 volts, and that's showing 3.758 volts. Those are out of sync, but that's just because it's two random cells that I picked up. What I will say is that I'm planning some big changes on how I've done this, with regards to how the AT Tinies are reporting it. Now the AT Tinies, I've found once they're calibrated, they're fairly accurate, and probably accurate enough for myself. An external ADC would be better, but at the moment they are pretty accurate. But what isn't accurate is the way that it's reporting it back via the opto-isolator and being read, using the pulse-in method. It works, but yeah, it's a bit wishy-washy, and that's something I'm not happy with. So what I'm looking at is a few different ideas, and if anyone's got any ideas out there, it'd be great. But kind of looking at maybe he's running the AT Tinies as an IC squared slave, and then communicating via an opto-isolator. I've bought some chips that'll be on the way that do allow you to isolate IC squared bus. So that's one possibility. Those were SMD chips though, that's the only pain, rather than through-hole components. Another method is to maybe stick with the opto-isolators I've got, or 2-channel opto-isolators, and maybe try going for emulating a 1-wire type scenario. Not sure quite how that'll work, so I'm going to do some testing in using either of those protocols would allow the information to be sent across. And in addition, what it would allow it to do is maybe put a temperature sensor onto the board itself, so then you could measure the temperature of the board and alternatively the pack that it's hooked up to, and that would give a lot more flexibility, especially if it's I2C. That would allow 2-way comms, and then that would lead to the next another iteration. I should say another iteration after that, which was some kind of some resistors, power resistor on board, and then you'd be able to do some sort of balancing in effect, and that's going to be kind of a goal as well. So just a short video, just to show some of the new iterations and the new things we're coming up with. If anyone wants to chip in, by all means, that's fantastic. Do have the it's been uploaded already to GitHub, so the new code's up there. If there's any issues or anything you spot, if I've done anything silly, by all means, please just give us a shout. Okay, cheers guys, bye.